Hello, my name is David On from the KGSEA Math Circle, and today I'm going to talk about the brute force algorithm. Before I start, all the code in today's lecture is going to be in C programming language. So, before we talk about the algorithm, we're just going to briefly review the conditionals and iterations. The conditional statement usually consists of three statements: if statement, the else if statement, and the else statement. The code in if statements executes only if this if statement is true. Else if statements are executed only when the if statement is false and their conditional statements are satisfied. The else statements will only be run if all the if statements and else if statements are resulted as false. If you look at the picture, the first if statement is going to be executed as false because the conditional statement is that x is less than 4, but 5 is not less than 4. Now we're going to look at the else if statement since the if statement is false. When we look at the condition, y is greater than or equal to 10. Since y is 10, it meets the condition, which will lead to executing the code inside the else if statement. The else statement will not be executed since the else if statement was already executed. For the iterations, it's really simple. We're just repeating the same process over and over. There are two types, the for loops and the while loops. We use the for loops when we know exactly how many times we're going to iterate, and while loops when we don't know how many times we're going to iterate. If we look at the picture, we can see that we can use the for loops when we already have the value y initialized as 10. And that we use the while loop when we don't know what the value of a is. One important thing for the loops is that we always need an increment or decrement of the loop control value, in this case the I or a, or either the loop will go on forever. So let's dive into the brute force algorithm. What is a brute force algorithm? It is a method or an algorithm that solves problems through exhaustion. It basically goes through all the possible choices to find the optimal solution. Now, let's say that we're going to find the pathway that goes through the least number of kilometers and that we need to go through all A, B, C, D. Plus, we cannot go back to station A after we move to another station. Other stations other than A can be revisited. How can we find the optimal solution? If you look at the figure, we can know that there are 4 possibilities, and the one with the 18 kilometers is the best. How did we know that 18 is the best? We went through all the possibilities to find the optimal solution, which is the shortest kilometers of travel. That is the mechanism of brute force algorithm, going through all the possibilities to find the optimal solution. The benefits of brute force algorithm is that it is simple and consistent. However, brute force algorithm can be very slow based on the input size, as increasing the input size means that there will be more possibilities to check. One example of these disadvantages can be shown in an article called Using Random Search of Brute Force Algorithm in Factoring the RSA Modulus. If you look at the table from that article, the column N is the input size. We can see that as the input size increases, the number of searches increases as well as the time. So taking a lot of time is basically an advantage of the disadvantage of brute force algorithm. Now, let's try to solve a coding problem using the brute force algorithm. This problem is called Jack. The problem says, in Blackjack, a popular card game, the goal is to have cards which sum up the largest number not exceeding 21. Murko came up with his own version of this game. In Murko's game, cards have positive integers written on them. A player is given a set of cards and the integer m. He must choose 3 cards from this set so that their sum becomes as close as possible to m without exceeding it. This is not always easy since there can be hundreds of cards in the given set. Help Marco write a program that finds the best possible outcome of given game. So this means that out of the large stack of cards that we input in, we can only choose 3 cards that make up the largest number that doesn't exceed the limit number. For example, in the figure, if there are 7 cards and the limit number is 166, we need to find the largest 3 card combination, just like 8, 140, and 17, which add up to 165, or 14, 18, and 134, which add up to 166 itself. So the input is going to be consisted of 2 lines. The first line is going to have the number of cards with a limit of between 3 inclusive and 100 inclusive, and the number we should not exceed with a limit of 10 inclusive, and and 300,000 inclusive. The second line is going to consist of the number of cards we put in the first line, and it can be any positive number less than 100,000. The output is going to be one number, the largest possible sum that we can obtain. For example, if we have 5 cards and their limit is 21, we can add 5, 7, and 9 to get the 21 itself. Now let's think about it. First, we must get the 2 lines of input. We will use the variable x to input the number of cards, and the variable com to show the limit number. We will also initialize an array with size of 105 to implement the card values based on the number of cards. Then we will use the for loop to enter the card values into the array. Now, it gets a little bit complicated. We will need to make 3 nested for loops since we are choosing only 3 cards out of a stack of cards. So for the outer loop to loop once, the inner loop needs to iterate maximum times it can iterate. For example, if x was 5, the 1j loop, for 1j loop to iterate once, the k loop needs to iterate 5 times. So it'll be 0, 1, 2, 3, 4. This nested loop will work 125 times, as it'll run 5 to the power of 3, which is equal to 125 times. For every iteration, it'll calculate the sum of 3 cards if the cards are picked again, because we cannot pick the same card according to the rules. If that no pick card again rule is satisfied, we will check if the sum we have is less or equal to the limit number, and if it is greater than the current maximum number. If that condition is met, we will update the current sum to the max, and if it's not met, we will just continue to the next iteration. So thanks for watching this lecture about the brute force algorithm, and I hope this lecture contributed to your learning of algorithms and computer science. Thank you.